Okay, here we've got the second topic of Year 10, the higher trigonometry. I've got my calculator ready here. Just one thing to remember with your calculator, you always want it in degrees. So if in doubt, something we do for exams, we say do shift 9 3 equals AC. That does a memory clear, and it means you've got that little d right at the top. If you can see it, that means it's in degrees, so perfect for when we're doing these type of questions at GCSE. So let's have a look over here at question 1. In all questions, give non-exact answers to 3 significant figures, so we'll remember that. And then what we've got is calculate, and that symbol means angle, Q to R to P. So if I go from Q to R, it's a bit of a rubbish line, and R to P, the angle that I'm trying to calculate is that one in there. Okay, so I'll tidy that up a little bit. But always remember, you essentially, when you're finding angles, you're finding 2 lines that intersect. So that is it. I usually call mine X. Then what I've got to do is think, well, how am I going to solve this? Well, I'm going to use, because it's a right angle triangle, I'm going to use SOHCAHTOA. And when I'm using SOHCAHTOA, the first thing I've got to do is to label the triangle with the O, the A and the H. I personally only label the 2 that I need. Think about the angle is here. Well, opposite the right angle is 18, so that is the hypotenuse. And as the 12 is next to the angle, i.e. touching it, that is the adjacent. The one that's from P to Q is the opposite. I don't need to label that because I'm not going to use it. I then look on SOHCAHTOA for the A and the H, and the A and the H are in K, and all SOHCAHTOA does is tell me the order to put the letters in. C, A, H, like so. Now, when I'm trying to find an angle, I've got to realise that the cos or sine or tangent go with the angle, so it's the C that I'm crossing out. So when I rearrange it, C equals A over H. Now what I've got to do is substitute in. Well, I've called the angle I'm trying to find X, so essentially the cos of X equals A, which is 12 over 18. I'll remind you that on your calculator, the cos of X will actually be in brackets, so I'm going to write that in there now. Now, I want X on its own, and to get rid of the cos, I have to do the inverse cos, and we put the inverse cos on the other side, and that looks like cos minus 1. That's the inverse cos, and what we've got is of 12 over 18. So now I go to my calculator. First of all, to get the inverse cos, I press shift cos, there it is, inverse cos. Use your fraction button on the left hand side, then get my 12, my down arrow to get my 18, go across, close your bracket off, press equals. Here I've got 48.18, which is 48.2, because it wants it to 3 significant figures, and remember it's in degrees. That's good. Okay, second question. Show that triangle ABC is a right-angled triangle. Well, if it is a right-angled triangle, then we would expect Pythagoras to work. So I would say that A squared plus B squared equals C squared. Okay. When I'm using Pythagoras, the longest side would be the hypotenuse, or the value of C in this case, which would have to be the 13. A and B can be either of the other 2, so I'm just going to call the 12A and the 5B. So now I'm going to substitute in. So if it is a right angle, then basically 12 squared plus 5 squared would equal 13 squared. Well, 12 squared is 144. 5 squared is 25. And we should know that 13 squared is 169. Well, 144 plus 25 is 169. And as these things equal each other, yes, big tick, Pythagoras is true. Yeah, so a right angle. Sorry about the writing. A right-angled triangle. Okay? If it wasn't true, if these things didn't add up, obviously we say it wasn't a right-angled triangle, and the right angle will be there opposite the 13 squared.